Hello, and welcome to this video where we will develop an interesting example about distributions of random variables. Imagine one elevator, one machine that's used to carry packages that have a very big weight, and we know that the weight that these machines are able to carry vary normally with a mean of 200 kilograms and a standard deviation 19.6. So very big packages with mean about 200 kilograms. So now imagine that we select randomly one of these packages that the machine usually carries. We need to calculate the probability that the weight of this package is in the interval between 195 plus minus 10 kilograms. So that means, be aware with this format, that means 185 and 205. So, as usual, first of all, remember to define your variable. For us, it's going to be variable x, as you see here, first line of the solution. And in the writing, remember to make a good writing. It's going to be weight of a package. If possible, try to define the units, which would be here kilograms. And later, we will define the distribution of the variable. So remember that we use this symbol. It could be only one symbol like this to refer that this variable x behaves as a normal distribution with mean 200 and standard deviation 19.6. So that means that if we are talking about the probability that my x is between 185 and 205, we will have to compute the probability to be greater to 185 minus the probability to be greater to 205. You could have written this line as the probability to be less than 205 minus probability to be less than 185. Could be done in the same way. But we will do it like this, and please try to solve it in the opposite way. So, we just need to convert these values into zetas, as we learned in the course. So, it's going to be this writing. As you know, here we are emphasizing again in the parameters of the population of the distribution, the normal. And to obtain the zeta scores, we just have to, as you know, compute the difference between the value and the mean, and then compute the ratio over the standard deviation. So this is the first zeta score for one limit of the interval and another zeta score for the other limit of the interval. That will give us two values. So now you have to go to the tables of the standardized normal distribution and check what is the probability that a normal distribution standardized 0 mean standard deviation 1 is greater to negative 0.76. or negative n it's greater than 0.25. So in the end, we need to compute these values. The way we compute these values will change depending on whether you are working with a calculator or with one standardized table. Remember that it depends on which table you are working. But in the end, you need to reach to this result, which is 0.379. Next question that we are going to answer is to compute percentile 5 of this distribution. And maybe we may be surprised by this question, why percentile 5? This was a concept we learned in exploratory data analysis, but we can refer to percentiles in this unit about distributions because percentile have some classic and clear definition, which is the number that lives below 5% in this case of the distribution. So it's a concept that can be easily applied to the computations we are doing here in random variable distribution. So we are searching the value k, which is the percentile 5, and according to this definition, it satisfies that probability that x is less than k is 0.05. So what we need to do is to consider the k value that will leave 0.05 Be careful with that because we are considering the probability that a variable that follows a normal distribution with 200 as a mean, standard deviation 19.6. This is something like the probability that my variable that's characterized by these two parameters, 200, 19.6, is less than k is 0.05. So it's very, very important that you write here less than because this is the definition of percentile. Please do not write greater to. So the probability that a normal distribution is less than the corresponding standardized value for the z-score if we knew the value of k. So we don't know the value of k, so we cannot obtain the z-score, but instead of that, we could find the zeta value that leaves 0.05 on the left, 0.05 below. So this is what we are going to do. You go to the tables and then you search the zeta value in a standardized normal distribution, 0 mean, standard deviation 1, which is the value that leaves 0.05 below, and you will find that it's negative 1.645. Indeed, usually this value is between negative 1.64 and negative 1.65, so it's a value in the middle of both, so we take 1.645, but you don't need to be so accurate. You could work with negative 1.64 or negative 1.65. What's very important here is to realize that we need the negative because as the 0.05 is on the left, it's below, we are aware that the zeta is going to be negative. So the equation that's more important for us is this conversion of the z-score. So k minus is the value we are searching, minus mean 200 divided by standard deviation should be negative 1.645. And then the result will give me 167.76. Does it make sense? Yes, of course, because the mean was 200 and we are searching the value that's percentile 5, so it must be lower than 200. The meaning of this number would be 5% of values, because it was percentile 5, 5% of values of weight are lower than 165 kilograms. The last question we are going to answer in this problem is, what would it happen if we loaded 5 packages on the elevator? That means stacking 1, 2, 3, 4, and 5. That's a lot, but the elevator is usual. It's used to carry this load. So there are 5 packages that will be loaded on the elevator. So what would be the statistical model for the random variable weight of 5 packages? So what we need to do is to build a new variable that's composed of 5 packages. And remember that each package had its own distribution, which was normal, and it has 2 basic parameters, which were the mean and also the standard deviation. So to answer this question, we will consider that there is a new variable, which is the y, and this variable is obtained as the addition of 5 packages. So according to how we treat normal variables, you know that the mean of one variable, that's very important here, the mean, the expected value, the average, is usually represented as E. This is something we can read here, E of y. That's the mathematical expectation, the expected value of my y. And this can be obtained as the mathematical expectation of the addition of each of the variables. So it's a mathematical expectation of x1 to x5. So in the end, it's going to be the addition of 5 times 200 kilograms, which was the average value for a package. So on average, we know that this y variable has a mean of 1000. And something similar can be done for the dispersion, but pay attention, be careful with that. You cannot add 5 standard deviation. This is a mistake quite common that you need to avoid. If you consider the addition of 5 packages, the only thing that you are allowed to do is to consider the addition of 5 variances. So if you want to obtain the variance of your y, you need to add 5 times the variance of each of the variables. So 5 times the variance of one single package. So it's going to be 5 per 19.6 squared. It's very important because you receive the data of the standard deviation. So before you add, you need to square the value and then you will multiply this value per 5. It could be the case also that each package has a different standard deviation. There are some that are smaller, some other are bigger, but in this case, the 5 packages are similar, so you can just multiply the value per 5. But in the end, what we are doing here is to add 5 times the variance of the packages. So this is a variance of 1920, and in the end, if you obtain the square root of this value, you will obtain the standard deviation. So the solution is, we have a new variable which is the y. The y is composed of 5 packages, the mean is 1000, and then the standard deviation is going to be 43, which is the square root of 1920. There is another question that we're going to answer before we leave this example using this new variable we just created. Now, using this variable, we're going to create the probability that the total weight does not exceed 1100. And it seems to be very difficult, but indeed is not. You just have to continue working with the variable you just obtained. And using the parameters that come from previous section, you can standardize this value, the value of reference, the 1100, and obtain the z-score. The z-score, you know, that can be obtained as the value, we subtract the mean, and then we divide by the standard deviation, and the z-score is this value. So you go to the tables, or maybe you use the calculator, and with this you obtain the probability. The probability that the total load is less than 1100 kilograms. And does it make sense? Could be, because we are considering the addition of 5 packages, each of them with a mean of 200. So the total, the expected value for the mean, it's about 1000. So what's the probability that the total load is less than 1100? It's quite high. It's quite high because the standard deviation is about 50, it's about 43. So it's very unlikely that we have 2 very big packages that for any reason exceed these parameters. So it makes sense that the probability is 98.88. These type of reflections or critical assessments are not required as a result of the problem, but this is something that may help you to identify possible mistakes, or it can help you to develop your critical thinking when you are thinking about whether this makes sense in the context of the problem that we are trying to solve. Remember to practice a lot with the problems. Thank you for your attention.